Let's take the next step now in our development of these ideas about functions, mathematical functions. We're going to start talking about the notation that's used. And we're working from this handout, function notation and graphs. That's posted as a PDF in Canvas. So it's convenient to be able to assign a symbol to designate a particular function. And F is used most commonly, but you can also use other letters, G, H, P, Q. Think of the letter as the name of the function. If we have a function f, and if x designates an input value, then the corresponding output value is denoted as pictured here. We read that as f of x. So let's just take a moment to reiterate that. F of x is the y value that corresponds to x. So we're saying if we take an input, x, the input x corresponds to, instead of writing y, we're going to write this f of x notation for the output, but it just stands for the corresponding y value. When we see this symbolism, we got to say f of x. That's how we read that. And just be aware that does not mean f times x. So it's got nothing to do with multiplication of f times x. It just means the output that corresponds to the input of x. Now, I have an example here where I go back to the squaring function on the handout. So I pick this because it's one of the simplest functions we know. And by the squaring function, I just mean take a number and square it. So if we had a table of values, on the handout I talk about -3 for x, 3, -2, and 2. So if you square -3, you get +9. Square 3, you get +9. Square -2, you get 4. 2, you get 4. Okay, so there's a table of values for the squaring function. In function notation, we would write f of -3, f of the x value equals the y value, 9. F of 3 equals its y value, 9. F of -2 equals its value, 4. F of 2 equals its y value, 4. So notice that in parentheses goes the input, which is like an x value. Over here on the right side of the equal sign is our output, but that's equal to f of the input, right? The y value. And on the handout too, I say a little bit about how we're used to describing the squaring function by an equation that looks like y equals x squared. With this new function notation, we'll write this as f of x equals x squared. And just realize that these are two ways of expressing the same idea, the same thing. And in advanced math and in calculus, function notation is very, very common. So we have to get very comfortable with this function notation, f of x notation. So let's get down to the exercises here. So we're going to use f over and over again for the name of a function, but not every function is named f. In fact, if you have two different functions in the same problem, you're going to have to use two different letters to designate them. And it's kind of a similar situation with variables, like x is the most common variable, f is the most common function name. So let's, again, start exercises. We're going to go right ahead and start working on exercise 1 from the handout that I've rewritten here by hand. So we're working with this function, let f of x equals 3x minus 5. And we want to find f of 4, f of negative 1, down the line. So let's go ahead and compute each one of these. So I'm just going to recopy my function here. F of x is 3x minus 5. So f of 4 means replace x with 4 in this formula. So we take 3 times 4 minus 5. That's 12 minus 5, or 7. So f of 4 is equal to 7. F of negative 1 is equal to 3 times negative 1 minus 5. That's negative 3 minus 5, or negative 8. So we can just plug in and evaluate. Notice what's inside parentheses is an x value. What we get at the end is the corresponding y value. Now you can say f of m with a letter, could be a variable. You just replace x with that letter, 3m minus 5. If you have f of negative m, then you replace the variable x with minus m. So 3 times minus m minus 5. Now, with f of m, 3m minus 5 is all we can say. With f of minus m, we can say minus 3m minus 5. And you can stop there. That's really as far as we can go. You could factor out a minus sign if you wanted to. You don't have to. Now, notice that minus f of m is going to be something different. This minus sign outside the function notation means minus the quantity we got when we computed f of m, which we have up here, 3m minus 5. But it's minus that entire quantity, so I need grouping, and I need to distribute the minus sign to the two terms. That becomes minus 3m plus 5 in the end, because minus and minus 5 is plus 5. Next, we want to compute f of 4 plus h. And what I want to do, before we do that part, I just want to write down the expression for the function again. And I wish we used a different notation for functions. Instead of writing f of x, I wish we just wrote f of box equals 3 box minus 5. So I replace the x with a box symbol. Because really, what the function notation means is take whatever is written here and whatever is written in the parentheses here, recopy it in this position in the expression over here. So if we want to figure out what f of 4 plus h is, well, the 4 plus h is in the box, right? So we take 3 times whatever is written here, gets recopied over here. That's 4 plus h minus 5. So the entire expression 4 plus h gets put into that x position. I just think it's a little easier to see with a box than with just writing x's. You don't have to write the box. Now, I can simplify this a bit because we can distribute the 3. We get 12 plus 3h minus 5. 12 minus 5 is 7 plus 3h. So when you simplify, you kind of lose sight of where this expression originally came from. It's like in the earlier steps that we see what happened, and then the simplifying kind of hides things a little bit, I think. f of 4 plus h is something totally different, because here the function notation has nothing to do with the plus h on the end. It's like we're computing f of 4, which we did up above, right? That was 3 times 4 minus 5. And then we're just going to add an h on the end. And I'm just, the red marks here are just to help us think about what's going on here. They're not really part of the calculation, right? And we already figured out that f of 4 was 12 minus 5. And 12 minus 5 is 7 plus h. So that's our answer for f of 4 plus h. So just notice that these two are different. And we got one more that we want to do here, is this f of x plus h. Just one more time I'm going to write the f of the box equals 3 times box minus 5. Because to compute f of x plus h up at the top, I guess it's the last part of this problem, it's kind of like if I see x plus h in parentheses here, I want x plus h in parentheses here. The x in the x plus h has nothing to do, in a way, with the x of just f of x expression. Think of it as a brand new x in its own right. And so f of x plus h is equal to 3 times x plus h in parentheses minus 5. I have to distribute the 3. I get 3x plus 3h minus 5. Those are actually three unlike terms, so I can't combine anything. There's my f of x plus h. And we'll continue more exercises in the next segment.